Hello, everyone. You are welcome once again to today's lesson. And in today's lesson, it is going to be the last lesson on the topic rational functions and partial fractions. Okay, all right. So, our main task is to use all the concepts, all that we've learned so far, on or under this particular topic, rational functions and partial fractions. In our previous lesson, we are going to see how best we can employ them in dealing with some selected past questions or likely exams questions. Okay, some of the questions are directly selected from the past questions WASI. Okay, some I varied, so there will be variations just to meet exactly what I want you to know, the information I want to put across. So what we are going to do is, everyone will talk today. At least you help me or deal with the question through to the end. Okay, as and when I think we are fine, everyone can continue, then maybe I will ask you to stop. So everyone is going. So I am going to start, start with the presentation. Okay, so I'm going to roll the ball. Okay, so in this case, I am going to deal with question 1. So question 1, we are supposed to do what? Express this in partial fractions. So this is how best you are supposed to deal with it. So this is going to be my approach. Okay, so as usual, if for nothing at all, I know the first thing that I write is solution. Then after that, I will come and write, my major question number 1. Okay, then what am I supposed to express in partial fraction? It is this. So I will extract it. So giving, my 3 minus 2x all over, x plus 3, into what? X minus 2. And I will extend this one to cover everything there. Okay, so at this point, I will ask myself, proper or improper? Degree 1, numerator, denominator degree 2, so proper. I thank God I can resolve straight away or write the identity straight away. Okay, so thankfully I know that its identity will be equal to the denominator. Factors are already factorized. None of them is factorable. So I can write my identity. These 2 linear factors distinct. Each of them will give me 1 fraction. So I know I'm going to get 2 fractions. The first fraction, the denominator will be s plus 3. Plus the second fraction, the denominator will be x minus 2. The denominator is linear. My numerator should be a constant, so a. Denominator linear, my numerator should be a constant, so b. Okay, so at this point, single fraction all the way. So my denominator of the single fraction, which is my LCM, will be the same as the denominator that you have here. So s plus 3 into x minus 2. So now a will go into this. S plus 3 will go into this x minus 2 times. So it will be a into x minus 2. Then plus x minus 2 will go into my LCM, s plus 3 times. So it will be b into x, plus 3. Okay, my x is not looking pretty, but at least you heard me say x, so that's an x. At this point, what do we do? Equate the numerators. So we get 3 minus what? 2x, is equal to a into what? X minus 2. Then plus what? Your b into x plus 3. So at this point, linear factors, so we know always we have to do the cover up method. So I am going to look for the positive substitution. So s is equal to 2. So if x is equal to 2, I will get what? 3 minus, My professors, I hope you are following. Minus
Yes,
2, into
yes, sir.
2. Is equal to a into 2 minus 2 plus b into 2 plus 3. So there's a past question. So if you're able to do it, at least it gives you, that sort of encouragement. So this implies, or you can ignore the implication sign and come and write 3 minus 4. So I know that will give me minus 1. And that should be equal to, 0 here, this will go. It's 3, then I wrote b. What happened? So 5b. So I write, plus 5b. So 5b here. Okay, I write it again before I divide. Okay, so it's equal to negative 1 over 5 over 5. My b is not that pretty, but I'm not worried. Okay, I will know how to deal with it in the near future. Okay, so that is the value for b. I need to go and find a. In that case, I have to, okay, cover up this. So x will be equal to minus 3. So if x is equal to minus 3, okay, what do I get? I am going to get, okay, 3 minus 2 into minus 3 should be equal to, so I substitute here, a into minus 3 minus 2, then plus what? B into minus 3 plus 3. Oops. Okay, so that gives us what? 3, this will give you plus 6, so 9. Okay, should be equal to, this will give you minus 5, so minus 5, so minus 5a, forgive me. I cannot perform my division at that point, so let me clear. Okay, then this will give me 0, so I know that will be the last thing that I need to write on that step. So here I am going to divide by negatives. I'll write, okay, maybe 9 over negative 5 is equal to negative 5a over what? Negative 5. So I'll get a to be equal to minus 9 on what? On 5. Remember, you don't leave negative in your denominator as your answer. So at this point, I know the values of a and what? And b. So I can now draw my conclusion for the resolution. So therefore, what I was asked to resolve, 3 minus what? 2x all over, okay, x plus 3, okay, x minus 2, okay, will be equal to. So let's see which one is positive. All of them negative. So here I don't have a choice. I have to start with a negative. But I'm matured enough to know. If you are not matured, you carry out your first substitution. So I'm going to do that just to guide you. So A is negative, B is negative. So I don't have any positive to start with. So I will still start with my A. So minus 9 over 5. But the whole of that over your x plus 3. Okay, then, okay, minus, or you let me write it this way, plus the other one will give you minus what? 1 on 5. Okay, all over your x minus 2. Okay, I would have moved, okay, drawn my conclusion straight away with what I'm going to write, but because I want you to follow. Okay, so that's why. So this will not even attract. So here, I know I have to bring my 5 down. So it will be minus 9. Okay, then my 5 will come down and come and multiply the binomial there. So I'll put the binomial in brackets so that the meaning will not change. Then this plus or minus, the minus will come. Okay, then I know 1 will be my numerator. The 5 will also come down. Okay, and come and write, multiply the x minus 2. I'm done at this point. Is my point well made?
Yes, sir.
Okay,
Yes, sir.
very good.
Yes,
Okay,
sir.
so I am through with mine. I set the ball rolling. Okay, so at this point, I'm going to call you randomly to be dealing with questions as and when, okay, it comes. Okay, so this is going to be our second question. I'm giving you some few seconds to think through, then I will call you. You tell me how you approach the question, then I will write. Whatever that you write, you tell me, then I'll write it, okay, for you. So think through this question, then we'll resume, then continue. Okay, so at this time, I believe you are all done. Okay, you know your plan, how you are going to execute. Okay, this. Okay, so Prof. Delays, let's go. How you are going to approach this. Prof. Delays, are you there? When I call you, please don't let us waste time. If you don't respond, you know what I will do. You know the rule. I will give you yellow card. Go come back again. If you don't respond for the second time, and you will be removed. That will be your red card, and I'll report you. I'm waiting. Prof. Delays. It seems you've unmuted, but you are not talking. If you are talking and then I can't hear you, so you need to work on your audio or speak close to your mic and let me see. Prof. Delays, are you there? Because I don't remember you having issues with your audio. Okay, all right. We are not going to waste time. Work on the audio. I'll come back to you. Okay, Prof. Adam, let's go.
So I'll check whether the equation is a proper or improper fraction, rational function. So it will be proper.
No, so tell me what you write, and I'll
All
write
right,
for you.
given 5,
Just give in.
no, given 5 minus 2x on 1 minus x squared.
Okay.
Then the question is a proper fraction, so I'll write the identities.
So what? How will you write the identity?
A on
So identical
1
to.
A on 1 minus x plus B on 1 minus x all squared.
That's what you write.
Yes, sir.
Okay. All right. So listen, it's good I called you. After checking that your rational function is proper or improper, what did I tell you should do next? Where should be your focus? Right from
The
there.
denominator.
The denominator. So what's about the denominator? What did I say?
The denominator is a perfect square.
The denominator is a perfect square. Really? What is a perfect square?
The denominator.
I don't make you. Okay, I mean, what is a perfect square? How were you able to identify that as a perfect square?
Sir,
Okay, so please, okay, I want someone to tell me exactly what I told you should do. After the determination of proper or improper, what should you be? What should be your concentration? He said denominator, fine, but what do you do to the denominator? Okay, Prof. Seyram,
you check.
Please, you check whether the denominator is linear or quadratic.
that is it. Okay, that's your answer. Any other answers?
So you check if it is factorable.
Why the casa? Prof. Adum, were you the one?
Yes, sir.
So you knew this. Your head like mine. What were you waiting for? What were you waiting for? Ukumi, I'm a pressure concern me. Wekumi kwa. All right. Okay. So now you know. Obviously, there's no. I've given you all the tools. So like I wait. That's why I always tell you. I always pass that comment. Don't just write. Be very careful. Think before you write. You see, marks are precious. Okay, I don't want you to have maybe other grades that you realize that if you had been more careful, you'd have gotten, I mean, a better grade. So you can be careful. So be careful. That's my point. Okay, don't wait for you to have that experience. So your next is to check whether the denominator, okay, that you have there is factorable or not. Is it factorable? Prof. Adom, is it?
So I'm checking.
You are checking. Hey, what are you using to check? Okay, obviously a number squared minus a number squared. So difference of two squares. That's why you don't have to check. Just by looking at it, you should know, okay, by experience that this is factorable. So this will be equal to, okay, you get what? Now you are going to factorize. You cannot write the identity until your denominators are, or okay, the factors. So I will get what? 1, this 1 squared. So I'll get 1 plus x, okay, into what? 1 minus x. Remember, I gave you something of this sort prior to do. Okay, 16 minus s squared, and we did something similar in class as well, if not exactly the same thing. Okay, so indirectly, this is a Pascal. So at this point, okay, what do we do? Let's get the identity, then we'll stop, then continue. Prof. Adum, you are not done. Okay, we are through. I hope you all understand how I got this factorization.
Yes, sir.
Okay,
Yes,
difference
sir.
of 2 squares. So you should know. As for the difference of 2 squares was one of the factorization that you used to like in JHS. True or false? I used to like that as well. Okay, so now this will be quickly. Let's go. Okay, so this will be identical to, we can write the identity. In so Prof. Adam, let's go.
So A on 1 plus x is plus B on 1 minus x.
Okay. Okay,
So
so
can I bring the x first?
no, you can't bring, don't bring it. I've told you, I advise you. It means you people are not heeding advice. I told you, if your first term here, the quantity that is squared, that's what must be your first term in all your factors. Your second term, okay, the quantity that is squared should be the second term of all your factors. So that's exactly what you can see here. So each term, first term, x. Okay, so take note, you can't swap. It is this one that you can swap, but this one you can't swap. But the point is, I've told you, first term, the nature should be the same. Second term, the nature should be the same. So now let's go.
So the LCM.
Very good. So at that point, you are going to write equal to, take your LCM. Okay, so get the LCM, then we'll move on to the next question.
1 plus x into bracket. Then 1 minus x into bracket.
Okay, then give me the numerator.
It will be A into bracket 1 minus x
Very good.
plus B into bracket 1 plus x.
Very good. Okay, so let's form the equation then. Okay, we are done.
So 5 minus 2x equal to A into bracket 1 minus x plus B into bracket 1 plus x.
Okay, so at this point, we can all continue. So what will be your first substitution, Prof. Adam? If x is equal to what?
2. Negative 1.
Okay, then the next one.
If x is equal to 0.
Oh, you have two distinct linear factors. Set each of 1 to 0 and solve. Why are you going for 0? You've not exhausted your linear factors. It's when you exhaust that you go for your liberty values. So equate this one, that will give you x, 1 plus x is equal to 0. So x will be equal to negative 1. You said that. The other one will be 1 minus x is equal to 0. So 1 will be equal to x, or x is equal. So you do negative 1 and x to get your value straight away. All correct, my professors?
Yes, sir.
Okay, so to save time, we are not going to complete that. Later, you will complete it. Is that clear?
Yes.
Yes, please.
Yes.
Okay, all right. So, okay, the next question, question 3. Okay, so let's see. Okay, Prof. Yes, please, Adam. Any issues?
My connection, but it's okay now.
Okay, all right. Okay, so we are not going to continue. You will continue later so that we can cover more questions and even finish, okay, as we have planned. Okay, so the next question, okay, Prof. Inshira, let's go. Question 3.
You said I should know it.
No, that's not for you. It's for Prof. Inshira. I'm done Okay, you are done. Thank you very much.
Now we'll go to the substitution method.
Okay, so what will you write?
And let u equal
No,
x.
okay. The other one, did you see? I wanted to, that's why I went back, but I came back again. Do you see anything, okay, missing in, apart from assuming maybe you did everything right from here, got the conclusion perfectly. Do you think there's anything wrong with the solution? Anything that we were supposed to write that we didn't? I've advised you.
Yeah.
Hey, Prof. Inshira.
Sorry.
Okay, all right, please don't forget to number your solution. Very critical. Take note of that. Okay, I've told you that if the question is directly on top where you have constraints, you can choose not to number. But for consistency's sake, always number. Is that clear?
Yes.
Okay. All right. So Inshira, let's go. Prof. Inshira.
Let u equal
So
x.
I'll write let you straight away.
Sorry. Question 3.
Mhm. And please, if you
Given
please hold on. If you are okay, part of those who write this Q1, please don't write this. The question number is 1. Write 1. Take note. Q1, Q2, Q3. No, just write a 3 there, 2 there. Okay, that's the name of the question. So go. Let's go. That's just by the way. Then you write.
given 5
Mm-hmm.
minus 3x
Mm-hmm.
over x squared. No,
S
over
squared.
x plus over x minus 2 all squared.
Okay. Mm-hmm.
Okay. Let u
Very good, smart. Immediately you said, okay, substitution method, I was happy. Okay, that you equally don't want stress. So let's go. Let u be equal to,
x minus 2
okay, x minus 2.
in that implies that x u plus 2.
Okay. Let's go.
Therefore, 5 minus 3x
Okay. I guess you
x
can feel
minus
me
2 all
smiling.
squared
Okay. It's equal to.
equal to 5 minus 3 into bracket u plus 2 all over u squared
Perfect.
equal to 5
You write the equal to close to the margin. So 5 minus.
5 minus 3u minus 6
Very good.
all over u squared.
Okay.
Let's see. 5 over u squared.
5. No. After expansion, always check if there is like terms. I've told you.
Okay,
Or there are
so
like terms,
5
I should say.
5 minus 6
Which is?
minus 1.
Okay. Can I start with that?
Yeah, because they are both negative.
Very good. Okay. So minus 1 minus 3u all over your u squared. Okay. So that's the more reason why I didn't stop. So you get minus 1 over u squared. Okay. Minus 3u over u squared. You simplify, then you go and substitute. All correct.
Yes, please.
Okay, so thank you very much. Please, are we all fine? Any questions
Yes.
before we move on to the next question? Okay.
No, sir.
Okay, we thank God. Okay, so let's look at this one too. Okay, so this one, let me see. Okay, you should all think through whilst I am looking for. Okay, Prof. Irene, let's go. Question 4. Prof. Irene, are you there?
Yes, please.
Okay, so let's go.
Please, thinking, please.
You are what? Hello, you are what?
Please, I'm thinking, please.
No, this one there doesn't need any thinking through. I won't allow that at all. I won't take that as an excuse to. It doesn't need any thinking through. At least you have to start writing something before you think about thinking through. So let's go.
Okay, please. 4.
Mm-hmm.
Question 4. Given
Giving. Mm-hmm.
x minus 9
Mm-hmm.
over x squared plus 5x minus 6.
Mm-hmm. Okay, first question you ask yourself. So flow and let's go. Some of them are basic. You don't have to think through. First question you ask yourself. I'm waiting.
If it's a proper fraction,
It is a proper. So where next do you go?
use the identity.
No, you go to the denominator. Even if
Sorry.
someone says, so let's go. What do you do to the denominator? If you go to the denominator, what question do you ask yourself relative to the denominator?
If you factorize,
Okay, so you can factorize. You factorize. Okay, so let's go. Okay, so it means I cannot write the identity because my denominator is factorable. So I go and get the factors. And thankfully, leading coefficient is 1. So I can get my special situation in terms of the factorization. Get my x bracket, go and get the factors. Factors of minuses, that's when you add, you get positive 5. When you multiply, you get minus 6. Okay, factor pair. Plus 6 minus 1.
Yes, please.
Okay, so plus 6. Okay, minus 1. You write it here. So now let's write the identity. Then we are good to go. So this is identical to
means a over x plus 6 plus 9 over x
plus
1.
9.
Sorry, minus 9.
Minus 9.
Yes, please.
Hey, are you okay?
Hey. Sorry,
Let's go.
b over x
Ah,
minus 1.
why are you doing this to me? Minus 1. So at this point, we should be good to go. From here, dear. Okay, you've done about 70% of the work. I mean, you've untied the knots. So you should be able to go. Okay. Point well made. We can all continue from here, right?
Okay.
Yes, please. Okay, all right. So now let's move on to question 5. Okay, so let me see who will be on my radar. Okay, Prof. Irene. Your hand is up. Okay, so ask.
Please, for the factorization, what if you use 2 and 3?
If you use what?
2 and 3.
Oh, remember the factor pair must satisfy 2 conditions. You multiply this and this, which gave you negative 6. So the product should give you negative 6, and the addition, which is the sum, should give you 5. If you choose 2 and 3, the product is giving you... Well, it shouldn't satisfy only one of the conditions. It must satisfy both. You get it? Yes. So even if when you are asked, when it comes to factorization, if you are wrong, you should know. If you are in doubt, expand whatever that you are saying is factorized form of this and check whether you get the same expression. If you don't, then it means there is something wrong.
Yes.
Okay,
Yeah.
great. You are welcome. All right. Okay, so question 5. Let me see who will be on my radar. All right. Okay. Prof. Mercy, please show this question no mercy. All right. Let's go.
So you write 5,
Very good.
giving
Mm-hmm.
2
Mm-hmm.
on x squared minus 4.
Mm-hmm.
So after that, you ask yourself if it is a proper fraction or an improper fraction.
Bam. Let's go.
So say it's a proper fraction.
So where next?
After that, you go to the denominator
Perfect. What about the denominator?
and you check if it's factorial.
Okay, is it?
Say if it's a fraction.
I've told you, anytime you see difference, okay, first quantity, a second quantity, and you see difference, check whether each of the quantities are perfect square, quantity squared. So indirectly, you know that s squared minus 2 squared. Prof. Mercy, Afa.
Yes, please.
So give me the factorization and let's go. So you can write the identity. So let's get a factorized form of the denominator.
So if x minus 2
Okay.
into bracket
Okay. You want
x
minus.
plus 2.
Okay. All right. I always want to write the positive first, but it doesn't mean really matter. It's the same. Okay. So now let's go. So at this point, write the identity and let's go.
So
What will be the identity? Hello, my professor. Prof. Mercy. Are you there? Oh, I don't want to believe your network. Let me check. Prof. Mercy, are you there?
please, can you hear me?
Okay, I can hear you now. Let's go. The identity.
So say it will be a on x minus 2
Mm-hmm.
plus b on x plus 2.
Perfect. Okay, so at this point, the next single fraction, okay, equate numerators, do your substitution, then you are good to go. Okay, so thank you very much. So far, I think so very good. Okay, though you are helped along the line, but we are still learning. So any help that you get, next time when you encounter such a situation, it means you wouldn't need that help. Then that will imply that you've learned from what your mistake or you've acquired some knowledge. Okay, so now we are going to move on to the next question. Okay, which will be, so this one equally, I am going to, let me check my time. Oops, okay, so here I will just throw a little more light on it, then we move on. So the same thing proper. You write question number answer, giving this proper. Check if the denominator is factorable and it's factorable. Factorize, then write the identity using the factors, then you are good to go. Is my point well made?
Mr. Akman, please,
Yes,
can you
please.
come
Sir,
again?
please come again.
I said it's the same thing. Check. Okay, this one you write says giving this. Okay, this is proper. Once it's proper, the next thing you go to the denominator. Check if the denominator is factorable. It's quadratics. Okay, and it's likely it's factorable. Okay, or not. It's very likely it's factorable. Let me put it that way. So if it is factorable, you factorize into linear factors, just as we've been doing. Okay, then you proceed. Is my point well made?
Yes, sir.
Okay. All
Yes.
right. So we move on to the next one. So the next one, this is it. Okay, only that this time around, okay, let's get the identity. You should be able to move from here. So given that y is equal to this, so indirectly, I'll write 7. This is a little different from the other one. That's the more reason why I'm writing. So given y is equal to whatever that I have there, 2x minus 3 all over x plus 2, okay, into what? Into x squared, okay, minus 1. Okay, so at this point, you know, okay, just check proper. So can we write the identity straight away? If you can, none of the factors here should be factorable. But you can see that this factor is factorable. Is that clear? Difference of
Yes.
2 squares. So you can't write the identity. Immediately you write the identity, at that point you are doomed. So before you write the identity, your denominator, none of them should be factorable in your partial fraction in the identity. So I'm going to write this one as 2x minus 3 all over x plus 2 into the factorized form of this will give me s plus 1, x minus 1. So here I have 3 linear factors. So I'll get 3 fractions. So identical to a over x plus 2 plus b over, okay, x plus 1 plus c over x minus 1. Take my LCM, then move on. Is my point well made?
Yes.
Okay, any questions here before we move on to the next one? We are all fine. Okay, Prof. Refoa.
Please, how will we conclude? In our conclusion, we add the y.
No, you can you can conclude in y, but in any case, you can say that the question asks you to express y in a partial fraction. So it's supposed to be y is equal to the partial fraction version of this.
Okay, yes, please. Thank you.
Okay, all right, you are welcome. All right. Okay, so now let's come to this one. Okay, you can see that this question, we've done it. Okay, so here, which approach would be ideal?
Substitution approach.
Substitution method. Okay, so when it comes to that, it doesn't really matter whether it's proper or improper. Okay, so this one too is basically the same thing. Okay, proper, the denominator is factorable. So you write f of s is equal to this, which is equal to come and factorize the denominator into this. So what will be the factors in the denominator if you factorize this?
X plus 3, x minus 2.
Perfect. Okay, so you have linear factors, you are good to go. Only that your conclusion will be therefore f of s equal to the partial fraction. That's all. As simple as that. Okay, so then let's come to this. So I think probably this will be our last. Okay, but one
Yeah.
question. Yes, please.
Yeah, please, can you go back? I want to write a question.
Okay, capture instead. Don't write.
Okay.
Okay. And I think after today, I will send you the slides.
Sir, please, I'm done. Thank you.
Okay, so you are welcome. All right, so quickly, let's look at this one. Okay, we have 2 ways of dealing with this. I'm going to guide you. Okay, obviously, you can see that what we have here, okay, we are saying that it's identical to this. This is partial fraction, this is not. Okay, so what you can do is, in this case, you come and take this side, okay, resolve, then later go and compare. Okay, so I'm going to take you through the ideal way. After that, I will guide you to do the other way. So this is it. Okay, as usual, question number 10. Okay, what are we giving? Okay, so giving, okay, 2x plus 3 all over, okay, x plus 2, okay, times what? X squared plus 4x, okay, plus 5. Okay, this is identical to a over x plus 2, okay, plus what? bx plus c all over x squared plus 4x plus 5. So here, immediately you see the numerator of this one to be linear. It means this is not factorable. If you had it to be factorable, okay, we would have factorized and given it in another form. Okay, so you don't even check whether it's factorable or not. If you want to check, fine. But I can assure you, once it's coming from the question and we wrote BS plus C here, then it means plus C here, it means it's not factorable. Otherwise, wouldn't have given it a linear numerator. So at this point, this is what we are going to do. I'll write this side as a single fraction. So listen. So this will be equal to, as a single fraction, my denominator will be the same as this denominator, x plus 2, okay, because this and this will multiply. So x squared plus 4x, okay, plus 5. My professors, are you following?
Yes, please.
Okay, now this will go into this how many times? It will be this number of times a. So I will get a out, okay, then x squared plus 4x plus 5, okay, which is, okay, plus, now this will go into this, okay, s plus 2 times, but times this is a binomial, so I'll put both in brackets. So let me write the bx, okay, plus c, then times what? X plus 2. Okay, so I'm showing you the first way. So at this point, this is what you do. You come and write, this implies that, okay, so 2x plus 3 will be equal to, you equate the numerators. Okay, if you want to use the cover up, you use, but here I would advise you expand. So it's like identity, expand, combine like terms and compare the coefficients. Is that clear?
Yes.
Okay, otherwise, if you still want to use substitution, but I would advise you compare, okay, coefficients, and you use that one. Okay, and in any case, you are asked to find the values of A, B, and C. So here, when you get your A, B, and C, you don't go and substitute. Is that clear?
Yes.
Yes.
Just conclude. So let the question tell you or inform you as to what to do in terms of your conclusion. Okay, and the last question probably. Okay, so not this one. Oh, we have, I think this one too, you should be able to deal with it. This one, you factorize the denominator. Okay, then you proceed. This one, we'll look at it. Okay, this will be our last one. So obviously, this is similar to what we just did. You can take this one. Okay, in any case here, the partial fraction has been written for you. So the next step is to take the LCM. Is that clear? I mean, the identity, I should say, not the partial fraction per se. So the identity has been given. So it's like the first knot untied for you. Take the LCM, then go and deal with it, whether the cover-up method or the comparing of coefficients method, to find your A and B. But when you find your A and B, just don't go and substitute. Assuming maybe you found your A to be equal to 2, okay, and B, you found B to be equal to your calculation 3, then you draw your conclusion. Therefore, the question asks you to find A plus B. So it will be A plus B will be equal to 2 plus 3, which will be equal to what? 5. All correct? So the values that you get, don't go and substitute. Okay, just come and what? Add them, because that's what the question is looking for. It's looking for the sum of the two values here, A and B. Is my point well made?
Please come in.
Okay, so I said with this one, the question said, okay, if this is expressed in this form, it's identical to this, find the value of A plus B. So your conclusion should be for A plus B. How can I find A plus B? I can find A plus B when I know the value of A and the value of B. And I know how to find the value of A and B per what we've done so far. So here, if you write this as a single fraction, equate the numerators and you solve for your A and B, don't come and substitute, because the question that they ask you to write it as a partial fraction. It's a partial fraction that you will substitute and you end at the substitution. Conclude. Here, the question asks you to find the values of A and B. So when you find the A, keep it. Find the B, keep it. Don't conclude with any of them. Then you come and write therefore. So I'm assuming I did my A gave me 2, my B gave me 3. So therefore, A plus B will be equal to 2 plus 3, which will give me 5. So I'm assuming these are the values. Is that clear?
Yes, sir.
Just to drum home my point, I'm not saying that is what, or these are the values. Okay, so then the next one, similar. Okay, come and find the values of P and Q. Then you come and write, therefore, p squared plus q squared. When you were asked to find the value, don't come and write therefore the value of no. Just as I told you, if you're asked to find the value of x, don't write therefore the value of x. Just write therefore x is equal to state its value. So in the same way, therefore, okay, p squared plus q squared will be equal to, so in this case, if p gave you 2 and maybe you solved, q gave you -1, then I'm going to get 2 squared, okay, plus what? -1 squared, which simplifies into 4, okay, plus what? 1, which will give you what? 5. You end there. Is my point well made?
Yes, please.
Okay, so if that's the case, then with this one too, you were just asked to find the value of u. Okay, so take notes, try this one as well. So, okay, write this. Okay, the identity has been given for, okay, so you proceed from there. LCM, continue, find your u. You are good to go. You conclude with your u. Don't go and substitute. Okay, you were asked to find a u, so just substitute. Okay, so on this note, I think we are right on point. Okay, this will be it, and this will be your assignment. So I will capture it and send it to you. But it's very likely I will add a question on the improper, okay, rational function, just to be convinced and sure that you all know how to deal with that situation. Okay, so any questions before we bring the curtains down finally on, okay, this particular topic, rational functions and partial fractions? Any questions? So we are all fine. Okay, Prof. Refua.
Yes, I wanted to ask that. I wasn't able to join in the beginning, so the video be posted about the improper rational function.
Everything is on the platform.
The solution to that question.
Are you sure? Are you talking about today?
Yes.
Oh, but you know how.
Yes, please, today.
Is it a rhetorical? You know I will send a video.
Okay, yes, please.
All right. So, and work on the slides and send the PDF version of the notes as well, of the lesson notes, so that you can
Okay,
use
yes.
it for revision. So the next one will mark, okay, so that we know what is expected of you in terms of your presentation. So this particular assignment and another one that will come, like I said, we will mark. Okay, apart from here, any other questions? Anyone with any question, any contribution, what have you? Okay, if not, then we have brought indirectly, okay, the curtains down on rational functions and partial fractions. Okay, our next topic, very likely, most likely, okay, will be coordinate geometry 1, most likely. Okay, so thank you very much. Okay, God bless us all. And your contribution, everything, your suggestions, your answers to my questions, making the class very interactive, much appreciated. Okay, God bless us all. Bye-bye.
God bless you too. Bye.